Day 3, interpreting and comparing functions. Read the problem below, then explore different ways to compare functions. Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid. Mr. Brown also buys a used car. His monthly payment is shown in the table. Find and compare the rate of change and initial value for each function. So, the model it. You can create a table of values for Mrs. White's plan to compare functions. Her total bill is $3,000. So starting off in month 0, when she bought the car is worth $3,000. And her monthly payment is $300. So every month, the amount that Mrs. White owes goes down by $300. And that's going to happen every single month. We're assuming that she's making these payments every month, which she should be, until it's paid off. So it's going to take her 10 months to pay off her $3,000 car, which makes sense because 3,000 divided by 300 is going to give us 10. So it should only take her 10 months to pay off this car. The graph it. You can plot ordered pairs on the same coordinate grid to compare the functions. For each function, as the x value increases, the y value decreases, which makes sense because as the months go on, both people should be paying, or they should be owing less on their car because they're already paying for it every month. So the amount they owe should go down every month. Yep, it shows a negative rate of change, and you know it's going to be a negative rate of change because, so a negative rate of change because the amount owed each month should always go down, should always be less, let's say that, than the previous month. And we can just say that because they're paying down the principal. Okay. All right, and we will go ahead and move on. So yeah, moving on to the questions. So number 7 says, look at the tables on the previous page. How much does Mr. Brown how much does the amount Mr. Brown owes decrease each month? Oh, I was looking at the wrong one the whole time. Okay, so Mr. Brown's, his also goes down by $300 every month. If you notice, it goes from 2,400 to 2,100, then from 2,100 to 1,800, so on and so forth until he gets to month 8 where he doesn't owe anything else. So he's going to pay off his car sooner because they both have the same rate of change of $300, which is their monthly payment. So they actually both have the same monthly payment. But of course, Mr. Brown's going to pay he's going to pay his car off quicker because his car was cheaper to begin with. Okay, so how much does his amount owed decrease each month? $300. How much for Mrs. White? $300 as well. They already told us that. Number 8, what is your answer to problem 7? Tell you about the rates of change for each of these functions. They have the same rate of change. So this means that, and how does the graph show this? When we looked at the graph, in the graphic section, they both, you could tell that they would, these red and blue lines, they'll actually never touch because they have the exact same rate of change. No matter what, they're both going down by 300 every single time. So I'm not going to have something that veers off to the side and then all of a sudden they end up paying off at the same time. It's never going to happen because they're paying off the same amount every month. So these lines will never touch, and since they'll never touch, that makes them parallel. okay? So the graphs on the line appear to be parallel, or the lines on the graph. Said that so wrong. And of course, that also makes sense because if the lines are parallel, that means they should have the same rate of change, and they do. All right, number 9, what is the initial value for each function, and what are the initial values mean in the context of the problem? So for each function, for Mr. Brown's, I'll call this one MB, his was 2,400, and for Mrs. White, hers was 3,000. These were the initial values. The initial values are the total amounts each person paid for the car. Okay, and we'll move on to number 10. Fill in the blanks to write an equation for each function where x is the number of months and y is the amount owed. So Mrs. White's plan, where x is the number of months and y is the amount owed. Every month we know the amount owed is going to go down, so this must be our output, which y is always our output anyway. And to have a function, the output should be a function of the input. So the input is the number of months, which is our x. We know for a fact we should have initial value for both of them. And then, of course, since this is decreasing every month, we'll have subtraction. And then they're both actually decreasing by $300 every month, the amount that they owe. So for both of them, we have y, or for Mrs. White, we have y equals 3,000 minus 300x. And then for Mr. Brown, we have y equals 2,400 minus 300x. So for both of them, we have y equals the initial value. Oops, not that weird. The initial value plus the rate of change. And our rate of change just happens to be negative 300 because the amount owed is going to decrease every month. So that's how we're getting this. We just have a negative rate of change this time in this example. Okay. Does it take the same time to finish paying for the car with both plans? And explain why or why not depending on the rate of change and initial values. So the rate of change is the same for both plans, but the initial values are different. We can write that. Let's write that first. So what this means is that it'll take both of them a different amount of time to finish paying off their plan. So it will take more time to pay off a plan with a greater initial value. Okay, and we shall move on to the try it. Use what you learned to solve this problem and show your work on a separate sheet of paper. So below are two companies' rates for textbook rentals. What is the initial value for each function, and what's the cost to rent a textbook for 4 months from each company? So Company A, the amount they charge, or the total cost in dollars, which is their C, and M is the number of months. So you can see since M is the number of months, that means that $15 is, since it's sitting by itself, that's going to be the initial value. No matter what, you're going to have to pay them $15 to rent books from them. And you're also going to have to pay them $15 a month for that book. So $15 is the rate of change. But then for company B, they don't have any initial value. They don't have any extra costs you have to pay just to start renting from them. So initial value for company B is $0, and you know that because there's no added cost. But $19 is going to be the rate of change. So every month you're going to pay $19. So we already have that there. And then we just need to figure out how much it's going to be for 4 months at each company. So company A is going to be 15 times our 4 plus 15. And that's going to give me 60 plus 15, which is $75 as my cost. Company B is going to be $19 for the 4 months, and that's going to be just $76. So it's actually going to be cheaper to go with company A. So yes, they had that initial value, that starting cost, but their rate of change was ultimately cheaper than company B. And since the amount of months was so low, this was the first time that you probably would have had a cheaper value at company A. All right, so company A would have given, it'll cost you $75 there, and company B, it'll cost you $76. Rate of change for company A is our coefficient, which is 15. Initial value is the constant, which is also 15. And then company B, our rate of change is the amount they charge per month, and there is no initial value. And that is all for day